So now we've moved on from rational equations to rational functions. And essentially the process of figuring things out is almost exactly the same. The difference is that we're looking at a function and we're looking at domain and values as opposed to solving for the variable term x. So first we're asked to find the domain of f of x. Well, the domain of f of x is, for any rational expression, is going to be all real numbers except what makes the denominator 0. So if we rewrite this as f of x equals negative x plus 8 over what two numbers, we have a leading coefficient of 1, so what two numbers multiply to 12 and add to negative 7. So we know it's going to be x minus and x minus because we have a positive product and a negative sum. So x minus times x minus, and the two numbers that would add to negative 7 would be 3 and 4. So the domain, we know x minus 3 can't equal 0 and x minus 4 can't equal 0, so x can't equal 3 and x can't equal 4. So our domain is all real numbers except x equals 3 and x equals 4. Now we're asked to solve for f of x equals 3. So we can just take our function, so 8 minus x over x squared minus 7x plus 12, and set it equal to 3. So if we multiply both sides by the denominator we have on the left-hand side, or if we simply factored and then multiplied by the factors, we're going to end up with 8 minus x equals 3 times x squared minus 7x plus 12. So that's 8 minus x equals 3x squared minus 21x plus 36. So let's go ahead and write this right-hand side on the left-hand side. And we'll have 3x squared. And if we're adding x, so add x to both sides, and we'll end up with plus, or minus, sorry, 20x. That's negative 21x plus x. And then 36 minus 8 is going to be plus 28. And that is equal to 0. So with this equation, we would now go back to the methods that we looked at in previous sections, looking at factoring. We could use the rational zeros test. We could use trial and error based on 3 and 28. What we'll find when we do that is that it does factor, even though it doesn't factor very neatly. We're going to end up with, this is going to end up being x minus 2 times 3x minus 14. And that's going to end up giving us x equals 2 and x equals 14/3. I'll save the check for you. I can tell you that these are the correct solutions. And I would start with using the rational zeros test to determine what the possible rational zeros are. And then in testing them, start with the whole numbers. You'd end up with finding that x equals 2, or x minus 2 would be a factor, so x equals 2 would be a 0. And now we're asked to finally find the points on the graph at this function value. So what that means is we already know what we solved for was the value of the function was 3. F of x equals 3. and we got x equals 2 and x equals 14/3. So that's going to correspond to the points 2, 3, and 14/3, 3. So again, domain is based on restrictions of whatever would make the denominator 0 in any of the rational expressions in our equation. To solve for when the function is equal to a specific value, we take the right-hand side of our equation. We take the rational expression, we set it equal to 3, and then we solve for x. And then as far as the points are concerned, it would be the x values that we solved for, and then the y value that we were already given f of x equals.